employee or someone who has employees who work in an environment where there is potential for harmful, toxic, hazardous, or flammable gases to be present or already are regularly present? Do you have a safety plan in place that includes the equipment and gas detection instrumentation to protect your employees and yourself? A continual presence or a sudden and unpredictable rise in the level of hazardous and potential flammable gases can have catastrophic consequences. Fortunately, these types of incidents don't happen every day, but they do happen. Early detection is so important because employees can be alerted when there is an unsafe level of hazardous gases present at any moment, allowing them to leave or avoid these areas entirely. It can help prevent these unfortunate outcomes by protecting not only property, but more importantly, lives.
Come on in.
And take a seat.
Hello, everyone. I'm Lori Podesta with Dave Heiner Associates. Thank you for making the time to be here with us today for the Dave Heiner Community Diner. Today's presentation will be provided by Tim Wolk, MSA Safety's Regional Sales Manager, and will begin shortly. But first, here's a little information about Dave Heiner Associates. In addition to MSA Safety gas detection, DHA represents over 35 quality manufacturers specializing in equipment and instrumentation for water and wastewater treatment plants and pump stations. Our product offerings include pumps, valves, gates, dewatering, fiberglass shelters and flumes, odor control, aerators, screens, conveyors, as well as instrumentation including flow meters, automatic samplers, chemical feed mixers, and many more. DHA has 18 employees, including our experienced sales and application group and a hands-on inside sales staff. We also have a service department that does service and startup work on a lot of our products. As you may be aware, it's very important that facilities implement a safety plan, including gas detection, to protect your facility and the health and safety of all your essential workers. MSA manufactures high-quality and reliable gas detection instrumentation. Here are some of the products that MSA manufactures. MSA offers a wide variety of controllers that the gas detection monitors can be connected to directly. These controllers can operate individually to provide local displays and alarms, or they can be connected to a SCADA system with different output options available, such as 4 to 20 milliamp or Modbus RTU. Controllers have various ratings for both classified and non-classified areas. We can work with you to find out which controller best suits your application. Tim's presentation will be going over sample draw systems. As this feature is quite important to water and wastewater facilities, I want to explain the advantage this option can provide. Shown here is a typical pump station. Various unexpected conditions can cause a pump station to flood. If any electronics are located in the flood zone and become submersed, the instruments will no longer function. A sample draw system allows the transmitters and sensors to be located up out of the flood zone. Only tubing will be run into the potential flood zone, and the sample is drawn up through the tubing to the transmitter and sensor. The tubing contains a water stop filter, as shown here, that prevents any fluids from reaching the electronics. This is also a nice feature if you have high ceilings and need to detect methane or lighter than air gases. The tubing can then be run from the ceiling down to the transmitters. DHA also represents MSA Safety Equipment Division. Shown here are some of the products we can assist you with, from portable gas detection to safety glasses, hard hats, and fall protection equipment including tripods and harnesses. A lot of you are familiar with the MSA Ultima X shown on the left. This instrument has been a workhorse for many years. This product will be supported for some years to come as long as the parts are available to MSA. However, production of the Ultima X's new units will be discontinued on December 31st, 2020. Shown on the right is the MSA Ultima X5000. It has been widely adopted as the gas monitor of choice since its inception of April of 2016. It is MSA's flagship product in their fixed gas and flame division, serving markets such as water, wastewater, oil, gas and petroleum, chemical plants, and many industrial applications. Tim will mention these more in his presentation, but here's a few highlights of the MSA Ultima X5000.
The future looks bright. Introducing the Ultima X5000 gas monitor. When it comes to gas detection, we think differently. Featuring an all-new design with an organic LED display and bright status LEDs for extreme visibility. A revolutionary touch interface for tool-free operation. Stay connected and work smarter. Bluetooth connectivity puts real-time data in the palm of your hand. Do more with less. 2 sensor inputs reduce cost of ownership and doubles the sensing power. Sensors can be remotely mounted, mixed and matched to suit your gas detection needs. An identical mounting footprint to the Ultima X allows use of existing wiring and conduit, saving you time and money. New advanced XL sensor technology with TrueCal redefines reliability. This innovative technology compensates for environmental shift and sensor drift, extending calibration cycles up to 18 months. Let us cut your maintenance costs in half with a 3-year sensor warranty and a 5-year expected life. A revolutionary gas detector that provides peace of mind. Recalibrate your expectations. The Ultima X5000. Welcome to the future of gas detection.
MSA has recently put together a series of lightning webinars. This particular webinar relates directly to our marketplace. It contains some important information you should know about NFPA 820 regulations. And if you're already familiar with these, it's a great refresher. I will be right back after Tim's presentation to answer some questions submitted by you. Enjoy.
Hello, everyone. This is Tim Wolk, a regional sales manager with MSA. And today we're going to continue another topic on our webinar series. This one's going to be for the wastewater market, titled NFPA 820 Guidelines for Combustible Gas Detection. So I'll give a summary review of this standard and how it's important for our business. If we break up the segments of a wastewater treatment plant and collections, you'll see that there's really basically 2 operational segments. There's the collections department, if you will, of a municipality, what operates all the pumping stations that feed material to the plants itself. And then there's a plant itself with all the treatment processes that are set. So the standard is going to be broken up into these 2 different segments, but the standard does apply for both collections and plant. So what is the NFPA 820 fire protection standard? So the main concern is the hazard is the presence of flammable gas, methane. So basically what NFPA 820 does is establishes some minimum requirements for fire and explosion protection. So some of the main points of the standard is to reduce or eliminate the effects of fire or explosion, maintain the structural integrity of plant infrastructure, control the flame spread and smoke generation upon a fire, prevent the release of toxic products and combustion, which can be also very hazardous as these products are formed when fire exists. And then to maintain the serviceability and operation of the facility itself. So those are kind of the basic requirements for 820, what 820 does. So in our business, it's used as a design standard by engineering firms and facilities for risk assessment. Just so you know, it is really rare to have explosions in a wastewater treatment plant, even though the possibility does exist. And this is a headline I found on the web. In 2014, unfortunately, there was an incident in Santa Paula, California, where they were doing some transfer of waste between a truck and a tank. And they had a light-off explosion. There were some people injured. And you can see the devastation there, I guess, of the event. And then this headline was interesting that in the wake of the explosion, plants may be able to mitigate that issue if they would have followed the NFPA 820 standard. So there's the standard itself, and it's new now, 2020. They do pretty much update the standard every year. And as applies to our business, the standard recommends combustible gas detection sensors in pumping stations and areas of wastewater treatment plant. So section 3.312 is basically the requirement. So a gas detector must be used in presence of flammable vapors and gases to warn when concentrations in air approach the explosive range. So if you dig deeper, and today I won't be spending a lot of details about it, it's again a summary review, but as you go deeper into the standard, there's basically 3 tables that are called out at table 4.2, 5.2, and 6.2, and they break it up into collection systems, and then the different types of treatment, either it's a liquid treatment or solid treatment. And if you go deeper into the standard itself, you'll see things like scum pits, sludge tanks, thickeners, clarifiers. They require, by their unit operation and function, a CGD or combustible gas detection. Typically, it's going to be also noted that it would be enclosed. So indoor buildings will more likely require combustion gas detectors. So here's an example, a sample spec. Many engineers, when they do the project bids, they'll actually call out 820. So you can see this particular spec called out section 7.4 and 7.6, and then it specifically talked about tables 5.2, 2, and 6.22 based on the actual process or part of the plant they were going to be working with. So MSA has a lot of options, or several options, to meet 820. And so if you look at what we do, I've divided it up into 3 different categories. The first one's ambient air. And so that's our standard diffusion type monitoring. And then sample draw is when you have situations where you have bad access and you need, or flooding, you could use a sample draw system. And we can provide the system either supplied loose with pumps and the detectors themselves, or integrated into an engineering flow panel. The important thing is electrical classification needs to be understood for all this before you get started on design. So ambient air. So here's the first one that I'm mentioning, and this is our traditional diffusion design for monitoring air. You see the Ultima XIR, X5000 Plus is going to be mounted on the ceiling. And then what happens is, and the transmitter is down here below, you can see at the eye level, there's a sensor. And what we do is, the concern is, putting these detectors in. And one thing about ambient air, you want to make sure that you can't have flooding. So typically for methane, it's high, you don't have the flooding, but we can provide sample draws, which I'll talk about. Sometimes sample draw is good. If the ceiling's very, very high and the users don't want to go up, and it's maybe the access is really bad for very high ceiling, like in a digester building. So then we'll put particularly a pump right next to the transmitter, and we'll pull a sample from the top of the ceiling to the detector itself. So sample draw, this is kind of a key point. And what MSA does to follow NFPA 20 is we follow NFPA 70, the National Electric Code. And we also interpret and use the design guidelines NFPA 497. So that 497 is basically recommended practice for handling flammable vapors and liquids as they apply to electrical installations. So we do follow these 2 standards as part of NFPA 20 in our design for sample draw systems. So sample draw design criteria. So the important thing about drawing samples is, where is the sample located and what is the hazardous rating for the location of, if you will, the filter where it's installed. And if they're rated for C1, D1, Class 1, Division 1, Class 1, Division 2 per the NEC code, then you need to have an XP rating for your electrical components, or have the electronics separated by a boundary so that you prevent combustible gas from reaching the non-rated parts. So for example, if you have an open circuit in a box and you're pumping the hazardous material that contains methane gas, you want to make sure it's separated, where methane gas could potentially light off the inside of an enclosure with open wiring. It's interesting to note, for pumping stations, that is a very common application. Some of the samples are without ventilation, a C1, D1 situation, but a lot of users will downgrade the C1D1 class to C1D2 by doing air exchanges. For dry wells, you need 6 changes per hour or 30 intermittent air changes per hour, and wet wells, 12. So that just kind of gives you an example of what's done out there. But the important thing is, what is the criteria or classification of the sample when it's taken? So to meet 820, for flow panel, for actually pumping stations, we will use a flow panel. So there's one there on the right. We mount all the sensors on a panel with a tubing, with a pump, flow meter, and a 3-way valve for calibration. And we can add H2S and oxygen efficiency as needed. And these can be installed in a class 1, div 1 or 2 area. So this flow panel, the Tri-Gas Lite, has the capability to go either classification area, which makes it a real easy installation where you're not too concerned about which classification it is. So there's the panel itself. This is the panel we use for the WEFTEC show. And interesting here, we got a picture of it, but basically flow from the filter from the wet well, for example, will come through this 3-way valve, through the flow meter, through the infrared methane detector, through the H2S sensor, to the oxygen, and there's the pump back out to outlet. So there's kind of a really basic, simple system, very complex, very simple, I should say, versus complex. And we will offer a engineering drawing that shows how we build this with an order. So sample draw, again, more information about that. The Tri-Gas product, which was released a number of years ago, we basically do value add. So we add an enclosure, a heater for freeze protection, and alarming system. So alarming system would be the lights, strobe, and an internal buzzer. So for example, if the class 1 div 2 area, the sample is pulled from there to this box. This is a general purpose box, so this needs to be general purpose area. It's designed for that use. Or if it gets more complex and you have a div 1 sample, or need to place in a div 1 or div 2 area, we have other designs. Here's one, for example, where we're monitored to the inside of the box with a sensor to be sure LEO methane did not reach the LEO levels. And then if it does, we shut it off automatically with a power kill switch, if you will. And here's one where we separate electronics entirely. So gas can flow here without any concerns. These are all XP components. And then this is our protected box that would house the exposed wiring. So here's a good panel, a good reason, reason to specify flow panel, if you will. So this was an actual picture that was taken in New York metro area, but you can see that the user ended up buying loose sensors and gas monitors and pumps, and you can see sort of the spaghetti wiring, but the flow panel can actually do much better to improve this in terms of the installation. So NFPA 20 and other gases, just want to mention that it does not specifically address the toxics like H2S and oxygen deficiency. H2S, and mentioning here, it is a concern of a toxic, and many users will design it to have H2S detection in indoor treatment buildings, especially in the odor control operations, and then pumping stations themselves. There's been concerns, obviously, in small spaces without ventilation. If you open up or work on a pump, you could have the presence of H2S gas present. Oxygen's concerns is especially in smaller spaces because they are considered confined space for smaller, like lift stations and pumping stations. So oxygen is also added. And then carbon monoxide is common as well if you have internal combustion engine, trucks that deliver inside a building to, say, storage areas. And then acid treatment will also have other gases that we'll do for wastewater, but not necessarily recommended by NFPA 20. So the other standard that's often cited is an OSHA standard for confined space sewer system entry. This is primarily for portables, but we will have users who will follow the standard for fixed gas, and they'll add, of course, combustible oxygen, hydrogen sulfide, or carbon monoxide for this standard. That concludes my presentation today. We wanted to keep it in the lightning round and at this time. So if there's any questions, any further questions, please let me know. But thank you for attending.
Thanks, Tim, for sharing that presentation, and thanks to everyone for sending in your questions. Here are a few. Where is the best location to mount the sensors? This is a great question we hear all the time. There are three main gases monitored in a wastewater facility or pump station: methane, oxygen, and hydrogen sulfide, and occasionally carbon monoxide or chlorine, depending on the process. Methane gas is lighter than air, so the sensors should be mounted up high in a room near the ceiling. Oxygen and carbon monoxide should be mounted 4 to 6 feet from the floor or at breathing level, while hydrogen sulfide is heavier than air and should be mounted near the floor. MSA has this handy guide to use for reference. Feel free to contact us or email me for a copy of this guide. Our contact information will be provided at the end of this presentation. Another question is, how often should the sensors be calibrated? The simple answer is there is no simple answer. It all depends on in what kind of environment your sensors are located and your facility's individual safety plan. While the Ultima X's that are being phased out tended to be calibrated around every 3 months, the new Ultima X5000s with XL sensors and TrueCal technologies can last anywhere from 12 to 18 months between calibrations, a considerable manpower and cost savings. However, again, this all depends on each individual facility. And the last question we have time for today is, we have all new employees at our facility since our MSA gas detection system was purchased. We're not trained on the calibration procedures. Does Dave Heiner Associates provide training or calibration services for MSA gas detection? While DHA offers service, startup, and training on some of our products, in MSA's case, we prefer to leave these services to the MSA trained and certified technician who is located here in our area. MSA offers both training and calibration services for your MSA gas detection instruments. Please feel free to contact us for any information. If we didn't have time to answer your question here today, we'll definitely get back to you. Please feel free to contact us if you have any questions or need any assistance. And one of you lucky viewers will be randomly selected to win a Dave Heiner Associates swag bag. Please follow us on Instagram, YouTube, and our website. Be safe and stay well.
That concludes our luncheon for today. I'd like to thank you all for attending. We look forward to hearing your feedback. Please join us for next month's luncheon.